Machine learning is pretty much everywhere these days. It's behind your streaming recommendations, complex medical diagnoses, you name it. But for a lot of us, it can feel like this exclusive club that requires years of intense math and coding just to get past the velvet rope. The whole thing just seems, well, difficult to break into. But what if I told you that's not really the whole story? What if you could explore data, train some pretty sophisticated predictive models, and figure out how well they work, all without writing a single line of code? It sounds powerful because, well, it is. So let's just challenge that whole idea that machine learning is only for hardcore coders. All right, let's dive in. Meet Weka. It was developed way back at the University of Waikato in New Zealand, and its full name is actually the Waikato Environment for Knowledge Analysis. It's this amazing open source suite of machine learning tools that's been a secret weapon in academic circles for years, mostly because of its powerful but super user-friendly point-and-click interface. So we're going to see exactly how Weka works as this incredible starting point for anyone curious about machine learning. It really lets you focus on the core concepts, the what and the why, before you ever get bogged down in the how of all the programming. The real magic of Weka really comes down to a few key things. First, that point-and-click interface just blows the doors wide open for everybody. It also has this massive library of algorithms, so you can play around with everything from simple classifiers to complex neural networks, which are basically systems modeled on how the human brain works. And on top of that, it has fantastic built-in tools for data preprocessing and visualization, which, trust me, are absolutely critical steps in any project. All right, enough talk. Let's actually see what this looks like in practice. When you first fire up Weka, the main place you're going to be working is called the Explorer. And here it is. This is the Explorer. Think of it as your command center. You see those tabs at the top? Preprocess, classify, cluster. They basically guide you through the whole machine learning workflow, right from loading your data to training and checking your models. Yeah, it might look a little busy at first glance, but the layout is actually incredibly logical once you get the hang of it. And getting started, it's ridiculously simple. You just click Open File, find the data folder that actually comes with Weka, and pick a dataset. We're going to use the classic diabetes dataset. These files are in a format called RF, which sounds fancy, but it's really just a simple text file, kind of like a CSV, with a little bit of metadata at the top that describes all the features. So once the data is loaded in, the most important first step is not to immediately train a model. No. It's to actually understand what you're working with. It's about turning that raw data into some real insights. In this particular data set, we've got several attributes or features for each patient, things like their glucose level, their age, and so on. Our main goal is to predict that class label. Did they test positive or negative for diabetes? And as you're about to see, some of these features are way more useful for that prediction than others. Okay, let's look at two of these attributes. Over on the left, you've got the plasma glucose level. The colors tell the story. Blue is for negative, red for positive. See that clear trend? As the plasma levels go up, the bars get more and more red. That's what we call a strong signal. Now look over at pregnancy on the right. It's a lot messier, right? There isn't that same clear pattern, which tells us it's a much weaker signal for our model to use. And that, right there, is the power of Weka's visualization tools. I mean, in just a few seconds, without any code, we've already found a crucial insight. Like Josh Gordon from Google says, right off the bat, we can see this as a useful attribute. That's the exact kind of intuition that Weka helps you build so quickly. Now, data in the real world is almost never perfect. It's messy. Often you'll have different features on completely different scales, which can really confuse some of the algorithms. But Weka makes cleaning this up super easy. With just a few clicks, you can apply a filter like normalize to put all your numeric data on a common scale, like say from 0 to 1. Okay, so we've explored our data, we've cleaned it up a little bit. Now it's time for the main event. Let's train our very first predictive model. And I'm not exaggerating when I say this is basically a one-click process. Seriously, you just go to the Classify tab, you choose an algorithm, we'll pick a decision tree called J48, which creates a set of simple if-then rules, and then you just click Start. That's it. And bam, we're done. Literally, in the time it took me to say that sentence, Weka has already trained a whole decision tree classifier on our dataset. It's a pretty incredible feeling, seeing how fast you can go from just a spreadsheet of raw data to an actual working model. So what did we actually just make? Well, a decision tree isn't some kind of magical black box. It's just a set of logical, human-readable rules. The model output literally tells you things like, hey, start by looking at the plasma value. If it's below a certain number, then the patient is likely to test negative. It's just wonderfully transparent. Now, the first question pretty much everyone asks is, so, how accurate is it? And yeah, that's important, but we're about to see exactly why accuracy doesn't always tell you the whole story. So our model gets about 73% of the cases correct. But here's the crucial part. It's how Weka gets this number. It doesn't just cheat by training and testing on the same exact data. It automatically uses a technique called cross-validation, where it trains on one chunk of the data and then tests on a different part it's never seen before. This gives you a much more honest, real-world estimate of how the model will actually perform. But let's ask a more interesting question. Is 73% good? Is 99% always better? What if you could build a model that was 99% accurate, but was also completely and utterly useless for what you actually needed it to do? This is the classic example. Just imagine a really rare disease that only affects, say, 1% of the population. You could write a one-line program that just predicts healthy for every single person who walks in the door. Since 99% of people are healthy, your model would be 99% accurate. Sounds great, right? Except it would be totally useless because it would fail to identify the one sick person you actually needed to find. And this is exactly why we need to look deeper than just one number. And that's where something called the confusion matrix comes in, which Weka gives you automatically. It breaks down the model's performance into true positives and true negatives, but more importantly, it shows you the errors. A false positive means you're telling a healthy person they might be sick, but a false negative means you're telling a sick person they're healthy. And you can see how understanding those different types of mistakes is absolutely critical. So, as we start to wrap up here, let's just think about what Weka really is. It's not necessarily the tool you're going to use to build the next giant AI system for a big tech company. Instead, think of it as your own personal machine learning launchpad. So why does that matter? Well, first, it's an incredible learning tool for just building your own intuition. It's also fantastic for setting baselines. Before you spend weeks building some super complex neural network, you can run a simple decision tree in Weka in 30 seconds to see what's even possible. It lets you focus on the concepts, not the code. And that's the most important foundation you can possibly build. And that really brings us to the final thought I want to leave you with. Now that you know a tool like this even exists, and that machine learning can be this accessible, I want you to just think for a second. What problems are you curious about? What data could you get your hands on and explore? What questions could you finally answer if the barrier to getting started was just a few clicks?